You are asked to solve ODE dy by dx is equal to minus ky at k value 0.1. The initial condition is y of 0 is equal to 2 using PINN. Okay, so the required PINN is consists of one input node, that is x, and the bias value 1. You provide it to the hidden layer. Okay, the hidden layer is h and the weights are given. So for combining 1 and x, for 1 the weight is bh, which is 0, and here it is w, which is 1. So since here the nonlinear activation is sigmoid function, h would be sigma of wx plus bh into 1. Then next, this hidden layer is passed to the output layer. There again take a bias. Then output layer node is y cap, and here it is v, which is again 1, and here the value is vo is equal to 0. Right, so the value of y cap, which is simply, since the activation is linear, it's a linear combination of 1 and h, that is vh plus b naught. What is value of h? H is v into sigma of wx plus bh plus b naught. Now we got y cap, okay, which is y cap of x. Okay, then as we can see from the equation, we need a derivative of y in order to calculate the residual. So y dash of x is equal to derivative of this, that is v into derivative of sigma with respect to x, that is sigma dash of wx plus bh. Then derivative of wx would be w, and bh is constant with respect to x. B naught is also constant. So this is y dash of x. From ODE we can see dy by dx plus ky is equal to 0. This is the way to write the residual. So the residual would be r of x is equal to dy cap by dx plus k into y cap of x, which is nothing but dy by dx is this one, that is v into w into sigma dash of w x plus bh plus k into, what is y cap? Y cap is this one, v into sigma of wx plus bh plus b naught. So this is r of x. Okay, and we would be needing residual value at 1. So the residual value at 1 would be r of 1 is equal to, if you substitute 1 for x, then we get w v sigma dash of w plus bh plus k into v sigma w plus bh plus b naught. Okay, and similarly we will be needing initial condition residual at 0, that is e of 0 would be the initial condition we have to rewrite it as y of 0 minus 2 is equal to 0. This is the condition for the initial condition residual. So if you put e of 0 would be y of 0 minus 2. What is y of 0? We have y of x, that is this. If you put instead of x 0, then we get v into sigma of wx is 0 bh, so sigma of bh plus b naught. So this is e of 0. Okay, so if you put the values, r of 1 value would be, if you put the given values w and v values. W is 1, v is 1. So r of 1 would be sigma dash of w plus ph. W is how much? 1. Bh is 0 plus k is 0.1 into v is how much? 1, and this is sigma of w plus ph. W is 1, bh is 0, so into sigma of 1 plus b0 is 0. So now we need value of sigma of 1, sigma dash of 1. So let us calculate. We know sigma of x is 1 by 1 plus e power minus x, which implies sigma of 1 would be, you can calculate, it would come 0.731. Then sigma dash of x is, as we have known from the class, the derivative would be sigma of x into, which actually you can derive, but you have to remember this formula to make it fast. So which would be 0.731 into 1 minus 0.731. So 1 minus 0.731, again if you calculate, this comes around, for the case of 1, sigma dash of 1, okay, would be 0.197. Then if you do similarly sigma double dash of x, which comes sigma of 1 into 1 minus sigma of x into 1 minus 2 into sigma of x, so which means double dash of 1, because we will be needing this later, so I am calculating now. So would be, if you multiply these three together, you should get around 0.091. Then now let us go further. So we have already calculated residual. In the ODE, that is r of x, and we also calculated residual in the initial condition, that is e of 0. Now let us write loss function. L would be half into r of residual in ODE, that is r of 1 whole square plus half into e of 0 whole square. So now we need derivative of this loss function with respect to all the four parameters. All the four parameters we have, that is w, v, bh and b naught. So for example, if we need with respect to any parameter, dou L by, let's call any parameter as p, then it would be dou L by dou p would be r of 1 into dou r of 1 by dou p plus 2 to cancel, then e of 0 into dou e of 0 by dou p, where this p can be, it can be w, it can be v, it can be b naught, it can be bh. So this p represents all these things. So we have to calculate, we already have r of 1 value, e of 0 value from here. See r of 1 value, r of 1 value I have not calculated it. See, just substitute the values here. For r of 1 we have sigma dash of 1, which is sigma dash of 1 is 0.197 plus 0.1 into sigma of 1 is sigma of 1, sigma of x, sigma of 1 is 0.73 into 0.731. So you just sum these two, you will get value around 0.26. Then r of 1 we have, then e of 0 is how much? E of 0 is this, and we just have to substitute h value we have given with ph value is 0, so it would be simply sigma of 0, which since b0 is also 0 and v is 1, then sigma of 0 would be 0.5, right? So now we have r of 1 value, e of 0 value. We have to calculate dou r by dou p and dou e by dou p with respect to different values. Okay, so let us start with the first one, that is dou r by dou r of 1 by dou. Let us start with v for outer layer. So dou r by dou v. What is r? I will write it in a new page. So we have r of 1 is equal to r of 1 we have r of 1 is this. Rewriting again, r of 1 is equal to Vw into sigma of W plus pH plus K into V sigma of W plus BH plus B naught. Now we need to take derivative r of 1 with respect to V. So dou r of 1 by dou V would be, derivative of this would be, since this is with respect to V, all this is constant, so it would be W into sigma dash of W plus BH plus K into, here V is there, so this would be simply sigma of W plus BH. B naught would be derivative with respect to V, it would be 0. Now this value, if you substitute the values, W is 1, sigma dash of W is 1, so W sigma dash of 1 plus K is 0.1 into sigma of W plus base, that is again 1. So sigma of 1, we already calculated the value, sigma of 1 is, sigma of 1 is 0.73 plus 0.1 into, so sigma dash of 1 would be 197, 0.1 into sigma of 1 is 0.73. So if you calculate, it would 197 plus, it would come roughly around 0.26. Then next let us calculate dou r of 1 with respect to the other output layer parameter is BO. So if you calculate with respect to dou BO, then this is r of 1, we have to take derivative this with respect to BO. So if you do that, this entire part, first term, does not have any B naught, so this will become 0. For this first term is 0, this only second term will contribute, so it would be derivative of simply K into B naught, which would be simply K, and K value is 0.1. Then dou r of 1 with respect to dou W. With respect to W, if you take derivative, this first term has W here, so it will be V into sigma dash. V into sigma dash is already there, so here two terms is having function of W. This here it is having function of W, and here also it is a function of W. So we have to do it by parts. So first, assuming this W as a constant, we have to take derivative of this, then we get so VW is constant, then double dash plus W plus BH. Now we assume this as a constant and take derivative of this, then V into sigma dash of W plus BH. Right, so this is derivative of the first term, plus second term, it would be only one term is having this function of W, so V into sigma dash of W plus BH. B naught derivative with respect to W would be 0. So now putting the values, V is 1, W is 1, so this will be sigma double dash of 1 plus V is 1, this is sigma dash of 1 plus K is 0.1 into V is 1 sigma dash of 1. So just substitute the values. So sigma double dash of 1 value is, we have already calculated, it is minus 0.091 plus sigma dash of 1 is 0.197 plus 0.1 into sigma dash of 1 is 0.1 of this is 0.0197. Okay, so if you sum these up, you will get value maybe roughly around 0.125. Then we have calculated derivative with respect to 3. We have to calculate with respect to other parameter, that is dou r of 1 by dou v, dou bh, b naught over bh, which would be, now if you look at r of 1 equation, here bh is there and here bh is there. So here if you take derivative, it would be VW are constants, derivative of this would be sigma double dash of W plus BH, and then derivative of BH with respect to BH is 1, then K into, so derivative of B naught would be 0 because B naught is not a function of BH, and then this function only, so we have V into sigma dash of W plus BH. Now substitute the values, V and W is 1, it would be sigma double dash of this would be W is 1, BH is 0, plus K is 0.1 into V is 1, sigma dash of, again it would be 1. So sigma double dash of 1, we already have the value, which is minus 0.091 plus 0.1 into sigma dash of 1 value is, again sigma dash of 1 is 0.197. So you just calculate this value, which should come around minus 0.0712. So similarly we have to calculate with respect to e of 0, the function e of 0, I will rewrite it again. E of 0 is v into sigma of bh plus b naught. Now if you take derivative of e of 0 with respect to v, then we get, so with respect to v it would be sigma of bh only, okay, b naught is 0, derivative, then sigma of bh, what is the bh value provided, it is 0, so sigma of 0 is 0.5. then dou e of 0 by, with respect to outer layer other parameter is dou po, so then if you take derivative of b naught it would be 1, so done. Then dou e of 0 by dou with respect to other parameter, that is w, would be, here there is none of this is a function of w, so derivative would be 0. Then dou e of 0 by dou bh, right, so now this is the function of bh, so if you take derivative it would be v into sigma dash of bh, and v value is 1 and bh value is 0, so it would be sigma of 0, the value would be sigma dash of 0, derivative, so it would be sigma of 0 into 1 minus sigma of 0, which is 0.5 into 0.5, that is 0.25. Now we have already seen the formula for loss function, that is loss function is this. Now we got, so for example if you have to calculate dou L by dou with respect to, let's start with V, then it would be R of 1, so R of 1 into dou R of 1 by dou V, that is R of 1 value we already calculated, it is 0.26, R of 1 we have calculated, which is 0.26, so 0.26 into dou R of 1 by dou V, which we calculated now, which is also again 0.26. I think maybe this value, just check it, maybe 0.27 might come for R of 1, and if you multiply these two you will get the value for dou L by dou V. Then similarly you calculate for the dou L by dou BO, which would be R of 1 into, this is only first part, we have to also calculate with respect to, as per the last function, we have to calculate with respect to e of 0 also, the e of 0 into dou e of 0 by dou V, so which means R of 1 would be 0.27 into 0.26 plus E of 0 value we have calculated, which is E of 0 value. See, E of 0 value here, sorry, E of 0 value would be V into sigma of 0 plus B naught minus 2, right? So minus 2 would be, this B naught is 0, sigma of 0 is 0.5 minus 2, which would be minus 1.5. So E of 0 would be minus 1.5. Minus 1.5 into dou E 0 by dou V, which we just now calculated. Dou E 0 by dou V is here, which is again 0.5. Just substitute the values, you get the dou L by dou V. Okay, then similarly you calculate for the dou L by dou BO, which would be R of 1 into dou R of 1 by dou BO plus E of 0 into dou E 0 by dou BO. R of 1 value would be again same as this, that is 0.27 into dou R by dou B naught, which we calculated, which is 0.1. So it would be 0.1 plus E of 0 value, which we just now calculated. E of 0 value is minus 1.5. So it's minus 1.5 into dou E 0 by dou B naught. Dou E 0 by dou B naught is 1. So just calculate, then dou L by dou W, which would be R of 1 into dou R of 1 by dou W plus E of 0 into dou E of 0 by dou W. What is R of 1? It is 0.27 to R, this is we have calculated, which comes around 0.125 plus E of 0 is, E of 0 we have calculated, which is minus 1.5 to dou E 0 by dou W. Dou E 0 by dou W value is 0. Then just calculate, then dou L by dou BH, which would be R of 1 into R of 1 by dou BH plus E of 0 into dou E of 0 by dou BH. Now R of 1 is 0.27, dou R of 1 by dou BH, which is given where dou R of 1 by dou BH. So we have calculated, it is minus 0.712 plus E of 0 minus 1.5 into dou F 0 by dou BH is, which we have just now calculated, which is 0.25. So then get this value. So once you have the 4 values, then we will just calculate V new from the V old. V old is 1 minus alpha value into dou L by dou V. What is the alpha value given in the problem? Yeah, actually alpha value is not provided in the model paper question. So in case if it repeats in the exam, you assume some value of alpha, preferably 0.1. So 0.1 into dou L by dou V, which we have calculated here, which is 0.677. So then you will get the new parameter. And similarly, BO new value would be, initial value is 0 minus alpha is 0.1 into dou L by dou BO, which is 0 minus 0.1 into dou L by dou VO would be minus 1.473. Then W new would be old value is 1 minus alpha is 0.1 into dual by dou W, which is 0.034. Then similarly BH new, the old value is 0 minus 0.1 is the learning parameter into dual by W, which is minus 0.394. So you will get the final values.